Yes, I think I
So
can.
I welcome all the members of this group, including amateur and professional astronomers in this gathering this evening. Today we have very distinguished speaker with us, Dr. Pavan, and we have Dr. Kulkarni with us this evening, and Dr. Ranjita Deka will be our host of this session from Guwahati. I invite Madam Deka to start the session, please.
Thank you, sir. A very good evening to all of you present here today. Today is the 21st NASNI talk, and that is every first and third Wednesday we meet in this platform. And today we have a very interesting talk on sun, moon, and stars, the calendar in our sky, which will be delivered by Dr. Pavan Gramapurohit. He is from Indian Institute of Astrophysics, Koramangala, Bengaluru. Yeah. I welcome Dr. Pavan to this group to deliver
Thank
our
you.
lecture. And his introduction will be given by Mr. Narayan Bajaj. Will give his introduction. And Narayan Bajaj is a student at Royal Concord International School, Bangalore, in the 12th standard. So, Narayan Bajaj, please introduce yourself.
Few noises, ma'am. Yeah, perfect. Good evening, everyone. NASNI, which is the National Astronomy Network of IAPT, is a dedicated platform of the Indian Association of Physics Teachers designed to foster interest and engagement in astronomy and sky watching among students, educators, and general public. NASNI was created in January 2025 to bridge the gap between new sky gazers and experts by providing structured learning, mentorship, and observational guidance in astronomy and astrophysics. It aims to nurture curiosity, promote scientific temper, and connect enthusiasts with leading astronomers, astrophysicists, and experienced sky watchers. This evening, we have the 21st talk of this year. It is my pleasure to introduce Dr. Pavan Sir, a young and accomplished researcher in the field of planetary sciences, space physics, and solar terrestrial studies. Dr. Pavan is currently a DST-INSPIRE Faculty Fellow at the Indian Institute of Astrophysics, Bangalore, where he continues his research on planetary ionosphere and space weather processes. He earned his Ph.D. in physics at physics from Andhra University in 2023, carrying out his doctoral work at the National Atmospheric Research Lab, which is NARL. His thesis explored the characteristics of suprathermal electron in the Martian ionosphere, a topic on which he has since made several important scientific contributions. Dr. Pavan has previously served as a postdoctoral fellow at NARL, and before that worked as a junior and senior research fellow, contributing to multiple national research projects. His entry his early academic foundation include an M.Sc in astronomy and astrophysics from Bangalore University, where he ranked one of the top at his cohort, receiving the prestigious Sir C.V. Raman Cash Prize for excellence in physics and mathematics. He has undertaken diverse research projects at IIA, VIT, and other institutes, working on solar UV variability, coronal loop temperature diagnostics, and long-term chances in the sun's radius. His scientific output includes peer-reviewed publications in journals such as ICRIS Planetary and Space Science, and the Astrophysics Journal, focusing largely on Martian ionosphere physics and solar forcing and magnetosphere interactions. Dr. Pavan is also an active participant in the scientific community, having presented his work at numerous national and international conferences, including AGU, IPSC, STEP 2025, and Planetary Science Meeting across India. Alongside his research career, Dr. Pavan is deeply committed to teaching and public outreach. He has taught at multiple colleges as guest faculty and served as a scientific assistant at Jawaharlal Nehru Planetarium, Bangalore. He has guided both postgraduate and school level research students, delivered astronomy lectures in Kannada, which is the Bangalore local language, of nearly 1 million viewers, translated scientific material, and contributed scientifically to science communications, including authorities and translating books. With strong expertise in programming, data science, spacecraft extraction, and observational space physics, Dr. Pavan brings both depth and breadth to his planetary work. Please join me in welcoming Dr. Pavan and everybody to the 21st NASNI talk. Welcome, sir. Welcome. Sir, you're on mute. Pavan, sir.
Pavan sir, unmute please.
So, okay, now am I
Yes.
audible? Yes.
Yes,
Okay. So is it screen is visible now?
it is visible, sir.
It's visible. So, okay. First of all, thank you very much for that kind introductions. I'm really thankful that NASNI has given me this opportunity. So think like that. I think there's a very famous shows in the TVs nowadays. It's Big Boss. So think like that. We all are the part of a big boss. But the lot of I think probably you maybe are watching and all that. So the main condition or the things they will put is that you don't have any gadgets. You cannot carry anything, and then you have to be there in a days however days they want you to be there. But thing is that now think like that we all are in a big boss house, and then we don't have any gadgets to measure and things to do. But now we are staying there, and then we wanted to know how many days we are in the big boss house. Okay, so that's why I gave big boss house for astronomers. So we are all in this now, but what is the tool to understand that how many days we have spent in a big boss house? To do that, there are two things which we is that when we come out from the big boss house, what we can see is that a beautiful sky. Uh, it may be a day sky or a night sky, or we will call it like the celestial sphere. So this celestial sphere is the sphere where you will see a lot of all these stars, planets, constellations, moon. What you can think of, all these are there. So in that, there is something called these are some terminologies to start with, then I'll bring it out that why I bought all these things. So there is something called a celestial equator. This is kind of a equator, as you know, as the Earth has the equator, which is exactly half of the Earth. Like that, we have for a celestial sphere, we have something like a celestial equator, which is a great circle of the imaginary celestial sphere. And now I think
Now,
it's visible.
yes.
Yes. Okay. Okay. Basically what I'm meant to say is that here you can see that this is a celestial sphere. Celestial sphere is the sphere where you see all the planets, star, moon, whatever you can think of, all in the night sky or a day sky. In that, I'm defining few things now. It's one is the celestial equator. So as I already wrote it here, is a great circle of the imaginary celestial sphere on the same plane as the equator of the Earth. So as you seen the equator of the Earth, it's similarly like you have a celestial equator. And then there is a one more, it's called ecliptic. So basically ecliptic is in a vague way, you can just remember in that it's a path of the sun movement in that. So it's basically sun movement around the celestial sphere over the course of a year traces path along the ecliptic against the background star. So whatever those background stars and zodiac constellation, that I will come later. But just to remember that the ecliptic path is kind of a path of the sun which is going around. It's not only a path of the sun, it's also the path of other planets, and then moon also sometime you can see. Near the eclipse only these things will be moving around. And there is an interesting thing is that there is an intersection of this ecliptic and a celestial equator defines as a equinox. So there is this is it's very well known. So there is something like equinox, vernal equinox and autumnal equinox. There are 2 points. What is that equinox? As we know is that equinox is the day where you have equal days and equal nights. If you know. So what are those? Means there are points where sun appears to cross to the celestial equator. That's a point where that. So is that the sun will means every day is the same, like same day and the same night? What I mean to say is that assume that if sun rises morning 6 o'clock and sets at 6 o'clock in the evening, that means it's a 12 hours, right? So if I go to the next day, it will be whether it will be same that it will rise at 6 hours and then sets at 6 hours, 6 a.m. and the 6 p.m. This what I said that on the equinox day it happens. It happens like you have equal days and equal nights. But will it be same for all the days in the year? That's a question. So moment if I'm saying that with the sun, so we are looking now that, right? So to look into that, so we have just asked a question that where does the sun rise and sun set? So we all know that it rises in the east, sets in the west, right? Next question is that it rises at the same point every day? That's the next question. So now here is the things which we need to understand. Now here are some photographs. So what they have just taken the photographs of the setting sun or a rising sun, which you can see it here. So there is your left. There is a 15th March. The sun was setting at this point. And then when they photographed on 19th April, it was at some, if you can see, it started towards the right. And 10th May, little more right. On 17th June, much more right. Like you can see that the position of the set, it is changing with the time. Now, if you see the right picture, it started with the December. In December, when they took a photograph, the sun was setting at this point. As you go to the January, it shifted little left. And in February, little more. March, little more. Like that, if you see that by the time of June, it is at the one corner. And after the July, again, it is started going back. So if you again end at December, it's again the same point where it started. So if you can see that this is called as solstice, which is mentioned there. It's a December solstice and the June solstice. So what we concluded now is that, okay, sun is...
Someone has given something else, no?
Sorry?
Bhavik, please don't share anything. Bhavik, keep your...
Yeah, Bhavik is sharing.
Bhavik, keep your mic mute and don't share anything.
Yes.
Okay.
Now it's okay.
Yeah. So what I mean, conclusion we got is that, so if you are coming out of the big boss house and then looking every day what time the sunrise and which place the sunrise in sunset is happening, it is not happening on the same place. So it is maybe setting at different places or rising at different places. That conclusion we got it from the sun now. So next question is that, so now, yes, we saw that sun is rising at every day at some places here, and then very next day it has moved little right or moved little left. This is what we are seeing now. So moment if there is a sun, what we see is we see also a shadow. And there's a well-known thing is that whenever there is a sun, what we see is that we say that, oh, sun is our overhead. So it's the afternoon. So where is the sun at the noon? So if you are seen in the afternoon time, if you can see where is the sun, then you can see by looking into your shadow, you can say that, okay, sun is my overhead. Usually we say that sun is whenever it's like in the afternoon time, we say that whenever they will have a lunch break or sometime, we'll ask where is the sun? We say that sun is our overhead. Okay. Now in this picture, if you can see that there is a place sunrise and then there is a sunset, right? In the sunrise, in the summer time, if you can see that there is a pole here, and if you can see the shadow, it is very small, very short shadows you are seeing on a summer shadow. When it is on autumns and springs, it is little more elongated. And then when you come to the winter, then it is little more long. So what is happening then? So every time sun is and you are overhead, you mean to say. But when you stand there, your shadow casting on the ground has a different length. So why this is happening now? So in the summer, you're seeing shorter, and then by winter, you're seeing the longer. So the question comes that, is that every time sun will be on our overhead? So the thing is that why the sun, whether they are in overhead or not, to answer to that question, so there is one more interesting thing which we see is that, so there is a Earth rotation axis and the revolution axis are inclined by a 23.5 degree. Means what I mean to say is that Earth is not exactly like a straight. If you are seeing like this, it is just tilted. That actual tilted is 23.5 degree. So this 23.5 degree makes even equator also to move 23.5 little here. And then this is all from your geographic class. You know very well that there is something like there is a Tropic of Cancer and a Tropic of Capricorn.
Yes, sir.
Yes.
Yes,
So
sir.
yes. So in the northern hemisphere, we call it as there is something called a Tropic of Cancer. So where this Tropic of Cancer comes, this comes exactly at the latitude of 23.5 degree. So if you are on the northern hemisphere, like towards the Delhi side, if you are on that side, it is Tropic of Cancer, which is northern hemisphere. And if you come towards the equator and the down, which is towards the southern part of the India, then you will see at 23.5 degrees south, there is something called Tropic of Capricorn, right? So now, where are you? If they ask you a question, then you may say that, okay, I am in Delhi, I'm in Himachal Pradesh, I'm in Bangalore, I'm in some places like that, you may say. But actually, if somebody wants to understand that where are you exactly, then how do we locate you? So we locate you by looking into basically a latitude and a longitude of the place. So now if I say that my latitude is 13 degree and then my longitude is 77, okay, so probably he is in the Karnataka, Bangalore place. Like that, we want to associate. So our position. So now having that understanding, there's one important things happens with that axial tilt, that is seasons. So you all heard about that we have 4 seasons, right? So now we are little towards the December. I think now it's already November 19. So we are approaching December. So on December 21st and 22nd, there is something called a solstice. So it's called winter solstice. So what happens on that day? Sun is overhead on the Tropic of Capricorn. So where we are in the southernmost hemisphere. So in the southernmost hemisphere, he is there. So that point where our winter solstice starts. And then as we move towards the time, so what he is doing, he is moving from the south towards the north. And if you can remember known, and if you have a calendar in your home, the people start saying that now Uttarayana started. Okay, so what is Uttarayana means? That sun was extremely at the south on December 21st. And after December 21st, he started moving towards the north. So has he moving towards the north? Has he traveling? So extreme means that is 23.5 degree. So that's a Tropic of Capricorn. That's what I was mentioning. So sun was at Tropic of Capricorn at 23.5 degree. Now he started slowly moving. So 23.5, he reduced now 22.5. Now 21.5. Like that, he slowly start towards moving towards the northern hemisphere. Why? Again, there are a lot of Earth rotation and all that you have to consider. Just to look with this figure. So as he moving towards that, when he on the March 20 and 21st, we see he's exactly on a equator. So where it's called equinox. So what happens on the equinox time? So you are exactly that equator side, the sun. Yes. So that is what we started with that. When we started that there is something called a celestial equator and the ecliptic will match at the point where we call it as equinox. These are the points. So that one is the vernal equinox, which is happens on March 20 and 21st. And even if you can, if you have seen, there is a festival called Yugadi in south part of the India. We celebrate something called Yugadi. So that usually comes around this time in the March. Now, as we move towards the March to the next, he started moving towards the northern hemisphere. So as he comes towards the June 20 or 21st, it will be a summer solstice. So he will be at the extreme north, which is Tropic of Cancer. So now the question is that, or I will ask you to check where this Tropic of Cancer and Tropic of Capricorn comes. So that means now he started moving to the extreme north and he stopped that point where it is on June 2021. So now he will be in the complete north. From there, again, he will start because Earth is revolving around the sun, right? Yes. So now as this moving, now he slowly started coming towards the south. So that is what we call it as Dakshinayana. So from the Tropic of Cancer, he will be in the extreme of north, and then he will start slowly moving towards the southern hemisphere. Has he moving towards the southern hemisphere? The same thing happens. Has he gone up? Has he coming down now towards the southern hemisphere? Has he coming down? Again, he will meet the equator. So there, that is on autumnal equinox, which is on September 22nd and 23rd. So he will be exactly on the equator time. Again, what happens? The same equinox, so same number of hours of day and the night happens. Again, now he will start moving towards the down, and he will enter to the December, which is again the extreme of the south. And then from there, he will start towards the north, which is called Uttarayana. So whatever you saw the pictures of in the earlier, which I showed here, and if you can see that, can you see that on the December, he was here, and then he slowly started moving towards the Uttara, which is northern hemisphere. And then he was extreme north here, and then he started slowly moving towards the southern hemisphere. It's clear now? So what the picture was telling is basically where is the sun? So now, when you come out from your big boss house, and if you are watching every day and noting down where is the sun is rising, where is sun is setting, by that time, if you can mark it, okay, sun today rise at this point, rise at this point, rise at this point, rise at this point, it has reached this point, again it has coming back. By doing this, you understood that you have almost covered 1 year. All the 365 days has gone and 4 seasons you have completed. So now, as we told that similarly, this is what again the picture is telling about. The sun declination is exactly 23.5 degree on a summer solstice, whatever I explained now on 21st June, and exactly minus 23 degree on winter solstice, which is 21st December. So basically what happens, the sun rays is exactly parallel. They are falling in those equator regions, those latitudinal regions. That's what it is saying. So sun will be directly over on 21st June for a location on Tropic of Cancer, and 21st December location of Tropic of Capricorn. So now what happens on that day if you are in the Tropic of Cancer? So on that day, you will see sun exactly overhead because sun rays are exactly falling onto you. So when sun rays are exactly falling onto you, what you see, whether you will see a shadow. So it is difficult. Now you can do that with you take a doll and then you take a torch and then you move torch slowly up and down on that doll. So what you see is that now you can do this in your home. This will be a very good exercise to understand how that 23.5 degree and which is moving sun. So at the one point when you put exactly your the torch on the doll, so the doll will not show any shadow. Okay, so that day is called zero shadow day. So now the question is that when and all these days we'll see as a zero shadow day. Now, if there are, assume that I am in the equator, I'm the equator now. So when will be a zero shadow day happens? it will happen exactly on the equinox time, because during that time sun will be along the equator side. So all the rays which are parallelly hitting on me. So if I'm standing on the afternoon time, exactly sun rays are coming on top of my head and I'm not seeing my shadow. Now, as I move towards the north or the move towards the south, wherever that declination of the sun matching to the latitude of those places, there all the sun rays are very parallel. We will understand more on this now. Now, this is basically called what I was talking about, zero shadow day. Now, I have done a small calculation. This is a rough formula. Anyone can derive this. So what it says is that there's a n. N is basically number of days. So the number of days is 81 plus 365 by 2 pi into sine inverse of 5 divided by 23 and a half. So in this also I will tell you what are those. That 81 days is something like from the January, we think like that, how many days we have covered. So it will be like 81 days by March 21st. So that 5 is the latitude of the place, and 23.5 degree is the ecliptic. So that whatever the declination angle of the sun which carries, which is 23.5. So now if you put the latitude of your place, then you can calculate how many days it will take you to come the sun to your overhead. So the small exercise I have done, that is for 13 degrees. So Bangalore has nearly, I'm just making a rough number, not taking the exact number. You can, because since you have a formula this and you can just do it right now. So just add 13 degree in the 5. 5 is basically latitude of the place. If you can do that, then what you will find is that number of days. So it will comes around like 187 days or something, 181 days or 187 days or something. Now, if you calculate that number of, if you count from January to that 181 days, or some numbers it comes. I didn't. I think I have a calculation or something. So it will comes around April 25. April 25. So this is the 13 degree when it was in the, that you are seeing this equinox time, no? This is March. So we are calculating from the January to this 81 days, and for your latitude, which is 13 degree in my case, and you can calculate in your case, then it says is that the when the sun comes on overhead of my head will be on April 25th. So now next I can calculate this one more time. He will come on the overhead again, because there is one more equinox happens on September time, because this again is going here and then coming to the same latitude where he will match his declination, which is again August 17th. This formula is somehow matching with the northern hemisphere, because he started moving towards the north from the December towards the March, means he started moving towards the Uttarayana, which is northern side. And if you want to move towards the southern side, you have to just subtract with the 180 degree. So if you just make pi minus of sine inverse of this, will give you the southern hemisphere side, how many days you have to cover from the January. So if you can do that, what I will get is that roughly zero shadow day in Bangalore happens on April 25th, and one more happens on August 17th. So as you come out from your big boss house, and then you are every day looking where your shadow is falling, and then the day when you see that, okay, you are not seeing your shadow on that day, just you can calculate and understand, okay, where is my big boss house is located. Now you know how many days you have covered. From there, okay, every day you're seeing that you're counting 1, 2, 3, 4, 5, 6 like that. And the day when it comes that your shadow is exactly 0, then you will know that, okay, these many days I have covered. And then I have a formula like this. Okay, now my phi is this, means this location falls in somewhere in this place. Like that also you can do. Okay, this exercise you can do from your places. Just what you need to know, you have to know your latitude of the place. Now I have a question for all of you. Now you people, some are there in the Delhi, some are in Himachal Pradesh and all those part. Can you just take your count of, or you note down what is the latitude of your place, and then try to insert in this formula and calculate whether zero shadow day happens in your place. Okay. So interestingly, I'll give out the answer because there is no kind of exercise I can make it. But answer is that no. So the people which are above 23.5 degree, this is what I was talking about. The overall, whatever the places which are above the Tropic of Cancer will never encounter zero shadow day. Similarly, the people like below the Tropic of Capricorn never see the zero shadow day. So overall falls between this Tropic of Cancer and the Tropic of Capricorn only can see the zero shadow day. Okay, so this you can try out from your place, because you're all staying there. Every day you can note down how your shadow is happening, and then from that this can be done. This exercise can be done in your every day in your school. You can just note down. You can put a stone, start keeping that. Okay, in this month on this day it is here. As our next goes, where it will be. So those exercise you can do, and it will be a really good exercise to understand how sun position is moving. Okay, so this is the again the same thing that calculation roughly made. This is for over the northern and southern hemisphere. You can see that it started from here because we are going with the India. So it's like 13th April, 29th August it started, because equator is just bottom of this. And then as we going here, you can see the different dates where zero shadow day occurs. Now, if you are in a Maharashtra, it does not happens on exactly on the equinox time, which is on March 21st, or another is on September. It will happen on 19th May, in the month of May. Those days where sun will be exactly on your overhead. So for a Bangalore, it is nearly on 24th April, 23rd, 24th April. You can see that. So this is a rough formula. With that, you can, I have given a calculation. If you can really do with that, you can try, you can understand this. Okay, when and all where the sun will be on our overhead. So this will gives us a rough understanding that, okay, how the sun is moving in the sky. Okay. Now, there's one more interesting things which I told you, that there is a something called a ecliptic, right? So in the ecliptic, what I said, that it is basically a path where sun takes around in the background of zodiac constellations. So you all know that in our that Hindu calendar, or whatever that we have constellations on the night sky, we have divided as a 12 zodiac constellation. So you know from Aries, Taurus, Gemini, Cancer, Leo, or something like Mesha, Rishabh, Mithun, Karkata, Katak, Sim, right? Kanya, like that we have known this rashis in that. Basically, what are these? These are kind of a imaginary patterns we have made so that we can understand the night sky better. So now what happens is that now as we are there here, now sun will be also is in the night in the sky, right? The stars are also on the sky and sun is also in the sky. Now in some place, sometimes what happens is that the sun will be in the background, or the stars, all these constellations, we call it as zodiac constellation. This constellation will be backside of the sun. So now in the morning time, so you know, right, there are still stars are there because sunlight is so much that we are not able to see them, right? If you want to see them, if there is an eclipse happens, full solar eclipse, then we can still see those stars, right? So all this constellation. To give an example now, what I mean to say is that now today, the sun, I can give you an example like in the July month. Okay. So what happens? Sun will be in the Cancer. He will be in the Cancer. Means the background stars are the Karkarashi will be there in the background, and the sun will be here. So what you mean to say that on that day, you cannot see Karkarashi and along with the 6, 3 here, 3 here. So in the night sky, whatever the 6 constellation which you are seeing, then daytime it is absent. Okay, those 6 will be there. As we passes with the time, the other 6 rashis will come, other 6 rashis will be in the bottom. Whatever the rashis, in to understand more better way, that's why I'm using that Rashi word, like Cancer, Leo, Gemini, and all that. So in the morning time, if it is sun in the constellation of Cancer, what we can't see the constellation like Leo, Gemini, Taurus, and Virgo. In the night time, we can see Pisces, Aquarius, Capricorn, Sagittarius, and Scorpio. This you can do it right now also. If you go in the night time now, so you can see the constellations. There are all different constellation you are seeing. You are seeing the Taurus now, right? Taurus is very prominent. You have Orion constellations, which we can see right now. So you are seeing them now, Taurus, Aries, Gemini, and all that. That means in the daytime, that the opposite 180 degree, whatever those are there, in those constellations, sun will be there in particular something. You got it? So other constellation will be there on the night time. So as time passes, sun will be also moving all along this zodiac constellations. To give an example, you can do this. In July month, sun will be in the Cancer. Okay. So what is the next constellation, which is Leo? What is the previous constellation? Is Gemini. Okay. This you can do. I'm just giving an example. Okay. You can right now also you can go and check. Now thing is that in the July month, what happens is that as the sun sets, sun is setting, and then if you look at the west side, you will also see a Leo. And then as it sun rising next day, you will see first Gemini, and then you will have a sun seeing. So from that, we can see that, okay, sun is in the Cancer. He is in the Karka Rash. Okay, that's what they say. That they when they say no, they even if you would have seen in the calendars or in some newspaper and all that. Okay, sun has gone to Cancer. Sun has moved to Kark Rash, Tula Rash, Mesh Rash. What is the meaning of that? That is that sun, the Rash is in the background, sun is in the front. Okay, so by looking into the sunrise and sunset, before sunrise and before sunset, we can understand that, okay, in which constellation sun is there. Okay, so this is an exercise you can do it on everyday basis. You just go tomorrow, just sunrise time, and then you can find out what constellation it is. Okay, and then you come towards the west. As soon as the sun sets, there's a one constellation just left behind. That is will be the constellation. So sun will be between that constellation and the rising constellation. So it will be in that center of the constellation.
Sir,
Okay.
we saw in newspapers.
Sorry?
Sir, we saw in newspapers.
Yeah, you will see in the newspaper saying that sun is moved to Tula Rash, sun moved to the Capricorn, Makar Rash, Kumbh Rash. You have heard about that, right? You also maybe read about those things. Okay. So now thing is that they have written like this, but you have to go and see it in your naked eye. You can see. So that's what I'm saying, that you just go early in the sunrise time and then you see a constellation near horizon. Means if you stand like this and then just rising part, you can see there is some constellation. And then you go towards the west side, setting time. As the sun sets, after that, there is one constellation. By that, knowing that, you can also find out that where is the sun. I think it's clear now, right? So now, so that's what I was talking about. Now, this is how you can look around and then calculate, like there is like Makara Sankranti, Mesha Sankraman. What is the meaning of Mesha Sankraman? Means sun has moved to Aries, like that. Okay. So now whatever you are seeing on the sky, that is not only a sun, you also have a moon, right? So with the moon also, you can now know how many days you are spending in Big Boss house, right? So to do that, what you need to do, again, you need to just watch how the moon. Okay, so what happens is that moons, you are all seen that it won't be always like a full bright, right? So it will be like just waning and waxing things happens. It will be like sometime full moon, there will be very small moon, it will be a very crescent kind of a thing. All these things happens. Why these things happens? Because you can see here, when you are on the earth here, and then sun, your moon is in front of you and sun is in the back side. So what happens? Earth will see a Amavasya. So we will not see the moon shadow. Moon will not see a moon. But when you come exactly 180 degree, what happens is that you are here midnight and moon is reflecting all the sunlight. So whatever we are seeing is that complete moon. So this is Purnima. So if you see your calendar, just now after this talk, you can just open your calendar in your home, you would have seen. So tomorrow is Amavasya, right? Amavasya, after that, what happens? There is a next day, which is called Pratipada, first day. Okay, if you can think like that, you can see here, this is the new moon, right? What is happening after that? Slowly moon is getting, it is increasing. So you can see that has seen new moon's here, and then it is slowly increasing, that moon, because shadow is falling on the sun, moon, and then you are seeing the slight visibility of the moon. So as you've seen like this, there is a fourth day, which is called Chaturthi or Chauthi. Okay, in a common word. So what you will see is that you will see a crescent moon, right? You would have seen that crescent moon, right? So that will be visible. And then as you move towards, there is a first quarter, right? This is called Ashtami. Ashtami means like the 8th day. You will see that exactly like moon will be half. You can see that. Or you can take a calendar in your home. If this calendar is not marked with the moon phases, what you can do is that every day you go and check how is the moon looking like. You can draw those moon in your calendar. Okay, tomorrow is Amavasya. Just make a black dot and go tomorrow next day, and then try to look whether that you are able to see a moon. If you are not able to see, or if you are able to see, how much you are able to see, just mark it out. Correct? Like that, if you can do a exercise, then by the time, or whatever the time it takes, I'm not giving it out now. So you can see that you are seeing all the phases of the moon, which exactly takes, if you are started with the Amavasya, by you come next back to the same Amavasya, you would have already covered some 29 days and some half. But are you basically saying that you have completed 1 month? Or you mean to say that moon has gone completely over the earth, means it has made a one complete rotation earth. Like that you can say. So this is what we usually call, this is the phases of the moon. Means what I mean to say is that by looking into just phases of the moon, you can get the timings or the days. You can count the days. That's what our calendar is doing. So in our side, what they'll do, after Amavasya, the very next day, our masa will change. It will be like, now we call it as Kartika Masa. Next, what is the next Masa? It will come that. After that, one more. Like that, it will be coming out. So I will give out all those things now. So basically, you understood now what is basically the waxing and waning of the moon, or a new moon, full moon, which is basically telling the duration, time after that. So now if you see that, you can see there's a full moon. There's a Amavasya here, west side. Now question comes that how to understand when is the Amavasya and when is the Purnima. Purnima or Purnima, whatever you call. So the Amavasya time, usually what happens, you won't see the moon, right? Means the moon and the sun should be on the same place. So what it means is that in tomorrow, if you go to, tomorrow is the Amavasya, right? Nearly we are in Amavasya. So if you go and see the sunrise time, you will also see moon. Okay, because sun and moon both are in the same point. As we go day and day and day, one point happens where sun is about to set and moon is rising. Okay. Oh, is there any questions? Or I can go ahead. Okay. So what is happening on exactly on Purnima day? The moon will be in the east and sun will be in the west. Okay. So you got it now. So on new moon day, sun and moon are both are rising in the east and setting at the west. But on the full moon day, sun is setting in the west and moon is rising in the east. Now question comes that how can you say that? So you can just do that calculation and then you can get that number. Or you can do, there's a thumb rule which you can remember this, that anyway calculation, all that if you want I can do it because I'm running out of time now. So just make a calculation that today, if tomorrow is Amasya, right? Think like that sun and moon are rising at 6 a.m. and sets at 6 p.m. Okay, you can do that calculation. The next day, moon will rise 45-50 minutes later. Means sun rises at 6 o'clock next day also, but moon rises at 6:50 a.m. So first day after Amavasya, next day, the moon is rising at 6:40 a.m. And you just again next day, the second day, this is first day, no, Pratipada. We usually in the calendar, if you would have seen. The second day, what happens is that you just add 45 minutes to that. 6:45 means around 7:30 a.m. What you will see? You will see moon is rise. So at morning, if you go to at 7:30 a.m., sun is already, it is rise, and then you are seeing there, and moon will be just rising in the east direction. If you start doing like this calculation, there is a point when it comes that sun is raised at 6 a.m. and sets at 6 p.m., but moon is rising at 6 p.m. So this is called Purnima. You got it? So this calculation, you can do it in your, like, in a pen and paper. This we generally ask school students to do this. So just they have to look every day moon, how it is looking like, and then they have to draw it. So by looking into that moon, basically phases of the moon, you will understand that how many days we have covered in a month. Okay, so like this months will go on. So to complete one full moon or new moon to new moon, for moon, it will takes 29.5 days. Means to complete 1 month for a moon, it will takes 29.5 days. Okay, but for Earth revolving around the sun takes how many days? You are generally saying 30 days or something like that, which is like 365.5, some 365 days. Now, if you can calculate 29.5 days, which is taking 1 month in a lunar calendar, for a 12 months, if you can multiply, then you will end up with 354 days. But your solar calendar means based on the sun. If you are, because Earth is going around the sun, we say that, okay, it is taking 365 days to complete one. So that means 1 year is completed. But if you are going with the lunar calendar, it has only covered 354 days. So to for in case of the solar calendar, how many days is left? 11 days is left, right? So to compensate that 11 days, we usually have something like Adhika Masa. So in some calendar, in the calendars, you will see this word like Adhika Masa, Adhika Shravana, Adhika Bhadrapada. Like that, you will see those in the calendars. Okay. So what is that Adhika is coming? That to compensate with the lunar and the solar calendar. So that 11 days we will add. After how many? 3 years. So every 3 years, we will increase that 33 days, and then we will increase one Adhika Masa of that month. Okay. So that to compensate, because we can match with the solar and the lunar calendar. So that leap year concept is different, and this Adhika Masa concept is different. So the leap year happens on 4 years once, but this Adhika Masa is with 3 years once. Okay. Now question is that now I was telling you that we'll call it as Masa or month. So why we call that month with that name? Because this is from the Hindu calendar, all that you can see. So we say that now we are in Chaitra Masa. We all say that Vaishaka Masa. Now we are in the Kartika Masa. What it means is that if you go to on a Purnima day, your moon will be exactly backside of Kritika Nakshatra. So that's why we call that month as a Kartika Masa or Kartika month of Kartika. So now, right now, if you go and see moon will be the moon exactly backside our moon is near the Kartika Nakshatra or the star. So that's why if you can point out that where is the Pleiades cluster and there is a Kartika star, and that point near moon is there on the full moon day. On full moon day, this is, remember, full moon day. Now when the next Masa is Margashira, and if you go to the full moon day of that, it will be in the Mrigashira Nakshatra. Okay. Similarly, on a Pusha, next Masa, then it will be in Pushya Nakshatra, Pushya star, like that. So all our Masa are the 12 month name, whatever we have named, is because of this nakshatra where moon is be in that. Okay, based on that we have divided all this 12 masas. So whatever in the calendar, whatever you are seeing, the Chaitra, Vaishakha, Jeshta, Ashada, Shravana, all this is because your moon is in that background of the stars. Okay, all the stars are in the background of moon, like that we can say. Okay, so now as you come out, okay, so I'll just want to finish with that because maybe if any questions there, and then at that time I can take. So basically when you come out without any gadgets or any calendar or something, just looking into the sun and the moon position, we can understand, or we can calculate, or we can know that how many days we are there, what are the many days we have covered, all those things. Even we can calculate what is the latitude of the place where we are actually there. If you are in the ocean and you found out that your zero shadow day is happening on that, okay, in which latitude you are there, like that we can do. So all this moon, star and sun will act like a calendar for you. If you don't know what actually you have a calendar with you, then only looking into this you can derive your own calendar and understand the sky or things like that. With this, I will just stop it at this point. If there are any questions or something, I will take you. Thank you.
So, anyone wants to ask any questions? Takshay, do you want to ask something?
There is one question, sir, in chat box from Sateja Rao, that, sir, what is obliquity?
So this is axial tilt I was talking about. I don't know what that obliquity is.
Obliquity.
Where they saw that. No, what I mean to say is that now if you can see that this obliquity is that this is normally in a perpendicular ecliptic plane. So now if you think that if Earth is like this, if you would have seen even globe also, if I keep it like this, but that axial tilt, that rotating axial tilt is just 23.5 degree. So that's the obliquity, which I mean to say. So this is the rotation axis. It is just tilted by a 23.5. That's the obliquity.
Meaning different
So
planets
you
have
can see
different
that
obliquity.
north-south line is, yes. Different planets have a different obliquity. Like Mars is in the Mars case, it is also 25, nearly that. So that obliquity is that much angle it is deviated from. Otherwise, if you just take the north-south is like this, and it is just tilted by a 23.5 degree in case of Earth. Yes.
Any question from Takshay?
No, sir. Sir, everything is clearly understand.
Very good.
So, okay. Now my thing is that if students are interested, I want to give everyone, like whoever wants to do this, just they can look into their shadow. One thing is about the zero shadow day, which I was pointing out. So that's an event everyone can watch. Everyone can watch, means who are all in the Tropic of Capricorn or Tropic of Cancer. If they are well within this zone, they can look into this zero shadow day, which is a prominent event, happens like twice in a year. So they can calculate and get that number when and all happening. And then one more thing is that the phases of the moon, which they can do it in their classroom exercise, that every day they will go out and then look at around 7 o'clock or 8 o'clock in the evening sky, and then just mark that shape, how a moon looks like. So this exercise we actually gave it to our rural students. So our IA, Indian Institute of Astrophysics, has a tie-up with there's a RDPR, Panchayat Raj commensurate from the government of Karnataka. So where we are educating um, to the rural people about this astronomical events and all that. Actually, there is a scope team headed by Dr. Niroj Ramanjam from IAA. So what we are doing is that we are educating this rural schools and then librarians and all them as at their regular exercise. Okay, so what they have done was that beautifully this moon phases they have done really good. So even they have taken the cream biscuit, that Oreo biscuits, and then they're just taken off every day how much they're like licking it out and then take it out. All those photos they have sent us. Okay, so that will be a really good exercise for other kids if you want to look into. So they will really appreciate how moon phases is changing from Purnima to Amavasya, Amavasya to Purnima. All those they can study with that. Yeah.
Any other questions? Anyone want to ask? I think.
Yes, Dr. Baba Sutar has informed everybody in the group that there is a app that is called Zero Shadow Day, named ZSD, on Play Store also. So we can use that also to find Day of Zero Shadow at our place.
Yes.
Thank you, Sutar sir. Thank you. Yes, madam. Time is running out.
Yeah. So if there is no more question, I thank you, Dr. Pavan, for your illuminating and very interesting talk. I'm sure everyone enjoyed it. Now I request
Yes,
Professor
ma'am.
to give his vote of thanks.
Thank you, madam. Now I'm here to propose a vote of thanks. Firstly, especially Dr. Pavan, who has spared his time from very busy schedule to address our enthusiast young kids and the group members for this very illuminating and interactive talk regarding sun, moon, and calendar, and very nicely related all these things like celestial, sphere, ecliptic, and rotation, revolution of Earth, and also concepts like zero shadow day or Tropic of Cancer, Tropic of Capricorn, and also related the zodiac signs and phases of moon. An interesting point concept of Adhik Masa also. So from NASNI, on behalf of NASNI as a coordinator, I extend thanks to Dr. Pavan Gramapurohit, and he is doing very good job in popularizing astronomy in rural area also from the given project he was telling us, and others can also do the similar at their areas. I'm also thankful to Madam Ranjita Deka, who was very busy, Madam, and but she spared time to host this session today. Thank you so much, Madam, on behalf of NASNI.
Thank you.
And also I'm thankful to our senior members of NASNI, Dr. Kulkarni, Dr. Baba Sutar with us, and Dr. I.K. Lenin, Tamil Kova, he is also with us, and all other members of NASNI with us, and especially young kids from across the India nation who are connecting with us, and they are very attentive in the entire talk and listening everything. That is why they are not asking question, because everything is made so clear by Dr. Pavan.
No, I'll drop my email ID in the chat box. So if there are any questions or something that they want to ask or they want to know more on that, or any even exercises and things like that, I'm happy to share to them. So I will drop my email ID in the chat box now.
Thank you. I'm also thankful to very young amateur astronomer, Mr. Naren Bajaj. He is a 12th class student from Bangalore, and he introduced our speaker today to our group. And thanks to all the participants today and making this talk useful for everybody. And once again, I thank Dr. Pavan for sparing time. And
Thank
I
you.
hope listen more expertise from you regarding your own research part at IUCA.
On Mars, I will definitely wants to give one on that.
Yeah. And once again, thank you all. And now we will sign off and see you in next 20-second talk.